Hello students, welcome to YouTube channel MANYATHA the Explorer. I am your lecturer Sir. In the session 9, we are going to discuss about very final part of this chapter, that is to derive expression for electric field due to uniformly charged spherical shell. In that, how to get an equation for outside the shell as well as inside the shell here. So in the previous session, we come to know that the applications of Gauss Law here. In the case of a uniformly charged infinite wire or conductor, in the case of an infinite plane sheet, how Gauss Law is going to be takes place. With the help of Gauss Law, we get an equation of what electric field ತಗೊಂಡಿದ್ವಿ. In the same sense, ಅದೇ ರೀತಿ ಏನು ಮಾಡಬೇಕು, ಈ ಶೆಲ್ ಒಳಗಡೆ to find electric field with the help of what Gauss Law ಯೂಸ್ ಮಾಡಬೇಕು ಅಂತ ಅರ್ಥ. So ಹಾಗಾದರೆ let us consider a point P which is going to be called as Gaussian surface ಅಂತ ಹೇಳ್ತಾರೆ. ಯಾಕೆಂದರೆ the symmetry or surfaces or whatever the dimensions which is followed by Gauss Law ಇದೆ. ಅಂದರೆ ಈ Gauss Law ಇದು ತುಂಬಾನೇ ಒಬೆ ಆಗ್ತಾ ಇದೆ. So for that reason this is going to be called as Gaussian surface ಅಂತ ಕರೀತಾರೆ. In the sense what, at a point O, center point ಇದೆಯಲ್ಲ, distance r ಇದೆ, the electric field is constant everywhere ಆಗ್ತಾ ಇದೆ ಅಂತ ಅರ್ಥ. So let us consider a point P outside the sphere and inner sphere whose radius is capital R. ಓಕೆನಾ, ಇಲ್ಲಿ ಚಾರ್ಜ್ ಎನ್ಕ್ಲೋಸ್ ಆಗಿದೆ ಅಂತ ಅರ್ಥ. So need to find out what a surface charge density ಯೂಸ್ ಮಾಡಬೇಕು ಅಂತ ಅರ್ಥ. So ಹಾಗಾದರೆ to calculate electric field due to outside the shell ಅಲ್ವಾ, so flux inside as well as outside ಏನಾಗುತ್ತೆ, in the sense what, let us consider a point P which is outside the sphere. Electric field is equivalent distance of R which is shown in the figure ಇದೆ. So electric flux phi of E equal to E delta S here. In the sense what, delta S is nothing but a surface of the sphere ಇದೆ. ಏನಾಗ್ಬೋದು, ಡಿಸ್ಟೆನ್ಸ್ ಆರ್ ಇರೋದ್ರಿಂದ E into 4 phi R square ಇದೆ. In this diagram or in this geometry we are going to apply with the Gauss Law ಇದೆ. So therefore Gauss Law is nothing but phi of E equals to Q by epsilon naught ಅನ್ನು ಯೂಸ್ ಮಾಡ್ತೀನಿ. ಯಾಕಂದರೆ how to calculate the electric field at a point P ಇದೆ ಅಲ್ವಾ. So for that reason with the help of Gauss Law, because Gauss Law signifies what, electric field only, so therefore Q by epsilon naught ಇದೆ. Say it is called equation number 1 ಅಂತ ಅನ್ಕೊಳ್ಳಿ, say it is called equation number 2 ಅಂತ ಅನ್ಕೊಳ್ಳಿ. Comparing these two equation ಏನು ಮಾಡ್ಬೋದು ನಾನು ಅಂದರೆ, in the sense E 4 phi R square equal to Q by epsilon naught here. Here is the surface charge density. In the sense what, distribution of charges around the sphere ಇದೆ ಅಲ್ವಾ. So therefore ಏನು ಬರಿಬೋದು ನಾನು ಅಂದರೆ, sigma equals to Q by A, area of sphere ಏನು ಬರುತ್ತೆ, Q divided by 4 phi capital R square ಇದೆ. If you want to calculate a charge, so therefore Q equals to sigma into 4 phi R square ಇದೆ. So capital R square. If we replace this value in terms of Q, we will get E equals to E into 4 phi R square equals to 4 phi R square into sigma divided by epsilon naught here. This 4 phi get cancel. Then the equation becomes ಏನಾಗ್ಬೋದು ಅಂದರೆ, E equals to this R square coming this side, then sigma R square divided by epsilon naught R square is there. So we know very well here. What about this sigma? Sigma is already known that Q by A ಇದೆ. So with the help of these value we will get, because to find electric field at point P ಇದೆ ಅಲ್ವಾ, the final expression becomes ಏನಾಗ್ಬೋದು ಅಂದರೆ, As you know already, electric field due to point charge ನಮಗೆ ಗೊತ್ತಿದೆ. The reason where the charges are going to be experiences what electrical force ಇದೆ. ಇಲ್ಲಿ ಕೂಡ ಒಂದು point charge ಇದೆ ಅಂದರೆ electric field ಎಲ್ಲ ಕೂಡ constant ಆಗಿದೆ. So therefore, electric field due to point charge is equals to 1 upon 4 pi epsilon naught Q by R square. So if the condition ಏನಪ್ಪ ಅಂದರೆ R is very greater than ಇದ್ದಾಗ ಮಾತ್ರ then the condition is going to obey ಆಗುತ್ತೆ. So therefore ಹೇಗೆ ಅಂದರೆ ಸಿಗ್ಮಾ ಕ್ಯಾಪಿಟಲ್ ಆರ್ ಸ್ಕ್ವೇರ್ ದೆನ್ ಎಪ್ಸಿಲಾನ್ ನಾಟ್ ಸ್ಮಾಲ್ ಆರ್ ಸ್ಕ್ವೇರ್ ಬಂತಲ್ವಾ, ಇಲ್ಲಿ ಆರು ಈ ಕ್ಯಾಪಿಟಲ್ ಆರ್ಗಿಂತ ದೊಡ್ಡದಿದೆ. ವಿತ್ ದ ಹೆಲ್ಪ್ ಆಫ್ ದಿಸ್ ರಿಲೇಷನ್ ವಿ ಕಮ್ ಟು ನೋ ದ್ಯಾಟ್ ದ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಔಟ್ಸೈಡ್ ದ ಶೆಲ್ ಬಿಕಮ್ಸ್ ಈಕ್ವಲ್ಸ್ ಟು 1 upon 4 pi epsilon naught Q by R square. So after completing the electric field due to outside the shell, we move on. The next one, field expression for inside this shell here. So we know very well there will be a surface charge density. Then dotted line shows the Gaussian surface here. Let us calculate electric field inside the shell. But thing is that there is no charges inside the symmetry or inside the shell. In the sense what? Electric field inside the shell is 0 ಆಗುತ್ತೆ. Then we can prove in mathematically. ಏನು prove ಮಾಡಬಹುದು ಅಂದರೆ consider a point P inside this sphere. The according to the definition of flux ಏನು ಬರುತ್ತೆ ಅಂದರೆ phi of E equals to E delta S here. So E as usual 4 pi R square. Say it is called equation number 1 here. So according to Gauss law ನಮಗೆ ಗೊತ್ತಿದೆ, ಏನು ಗೊತ್ತು ಅಂದರೆ according to Gauss law phi of E ಏನಪ್ಪ phi of E ಅಂದರೆ the total electric flux enclosed by the surface which is equal to 1 upon epsilon naught times enclosed by the point charge, which is meant for what? Gauss law ಇದೆ. So according to Gauss law Q by epsilon naught ಅನ್ನು ಬರಿತೀನಿ ನಾನು. So it is called equation number 2 ಇದೆ. Again comparing these two equation ಏನಾಗಬಹುದು, E 4 pi R square equals to Q by epsilon naught, where Q is 0 in the sense no charge is found in Gaussian surface. ಈ ಗಾಸಿಯನ್ ಸರ್ಫೇಸ್ ಒಳಗಡೆ ಯಾವುದೇ ಚಾರ್ಜ್ ನಮಗೆ ಕಾಣ್ತಾ ಇಲ್ಲ, ಸಿಗ್ತಾ ಇಲ್ಲ. In the sense what? Q should be 0. So ಹಾಗಾಯಿತು ಅಂದರೆ E 4 pi R square equal to 0 ಆಗುತ್ತೆ. Then to calculate electric field inside the shell ಅಲ್ವಾ, suppose ಈ 4 pi R square ನಾವು ಆ ಕಡೆ ತಗೊಂಡ್ರೆ 0 by anything ತಗೊಂಡ್ರು will get what? 0 ಬರುತ್ತೆ. So in the sense what? We will get electric field whatever the dimensions, whatever the symmetry. In the case ಬಂದಾಗ ಏನು ಮಾಡಬೇಕು ಸೂಕ್ಷ್ಮ ಅಂದರೆ the field inside, because inside of any geometry, any dimensions charge ಇಲ್ಲ ಅಂದರೆ electric field is becomes 0 ಆಗುತ್ತೆ. For that reason this is the expression for electric field. Here electric field is 0 into the inside the shell. So this is about expression for electric field due to uniformly charged spherical shell for outside the region as well as inside the region. Okay, thank you.